Okay, today we're down at the shop. I had my first real thing that I need to get repaired on the VMC. I know one of a lot of the holdbacks to a lot of people buying used VMC, and I'm by far, if you're building parts all day long, go buy a new machine. Me, I do hobby and prototyping only, and I bought a used machine. I've had this for a little over a year now. Without any major issues other than the initial setup. Machine's been running great. It kind of started as a slow problem. I started noticing the air compressor was cutting on a lot more, and basically I've got an air leak somewhere. Hopefully it's nothing big. It's just a kink line or something like that. I kind of have my doubts about that, simple because of the machine's age. Unless it's an old line. I have a feeling it's probably a seal in something that's leaking. Anyway, we're going to try to take a look at it today and hopefully come up with a solution. For those of y'all that have not watched my videos, this really doesn't bother me. I'm not, again, I'm not a machine shop per se. I do prototyping, so me getting into my own machine and repairing it is not an unusual day. By any means. I have a lot of experience with industrial machinery. Professionally, I do hardware design and software design. So this is just another day for me. Your situation may be different. However, for the amount of money that I spent on this and what I've gotten out of it, pretty much I had the machine paid for within the first 2 months of owning it. And that includes the month or so it took to actually install the VFD and get the machine up and running to actually produce parts that make money versus just doodads just to kind of calibrate things. I looked up, the machine was in great condition when I got it for its age, and the best I can tell, they were either running mainly probably aluminum or plastic, maybe even in this machine. I found a lot of Delrin, in the way covers and stuff. So the machine hadn't really seen a hard life. Anyway, we're going to get to it. I'm going to dig around. We're going to hook some air, and then we're going to start digging around and see if we can find out where this air leak's at, or at least get some kind of positional data on where the problem may be. Okay, we applied some air. Definitely can hear the leak. I may have two air leaks. I'm not really sure. It may be echo. It was really hard to tell. It almost sounded like you could hear an air leak on the inside of the enclosure. Definitely a bigger leak on the outside of the enclosure. And I think I've kind of narrowed it down to the area. I kind of filled around a little bit. It does not appear to be just a airline leak. It's actually leaking out of one of the vents on the solenoid block. Now on the Haas machine, they typically have individual solenoids with their own exhaust port, and those are a little, I won't say easier, because a lot of times it's really hard to get in there and swap out just one of those because of the way that they line up. This one actually has a manifold. I believe they're called ISO. I don't have a lot of experience with the integrated solutions, but they're basically very similar to the singular parts, and I'll kind of give you a better idea when I get over to the back of the machine. But basically, typically when you're building an industrial machine, you have a lot of air controls, and usually you'll stack those up. Well, on a lot of machines, especially US machines, they actually will use individual components that you can buy from McMaster car that are, they manually route air between the solenoid blocks with just a regular airline. This particular machine, it's a little more integrated. It actually has, I believe, it looks like a standard ISO manifold and solenoid blocks. I'll know more when I dig into it. But what they do is they actually have a stacking block that you can basically build your solenoid stack without having to manually route air in between them. So basically you stack, if you need 2, 3, or 4, you stack them on top of each other and then put an inlet and outlet at the top, and it feeds all the air and has an exhaust port typically, or you can route the exhaust port to one of the ports on the stack, and I'll show that to you here in a second. It sounds like I have a leak. It appears to be a 4-port stack, so that's quite a bit. That's pretty much all of the air on this machine, and it's mainly centered around the tool changer and the drawbar for the spindle. So finding it, I'm probably going to start the machine up, kind of use the different functions, and see if we have see if the air stops or changes. That'll kind of give us an indication of which solenoid it may be. Typically, the one ISO solenoid that I've dealt with in the past, I want to say it's Emerson. They were really easy to rebuild. Basically, they had a plastic body housing, and pretty much what always wore out was the outer exhaust port O-ring. So pretty much you would pull it apart, clean it, replace that O-ring, and you'd be back in business. These look a little bit different. They're probably a little bit different material. It's more like a Bakelite material, just tapping on it. So that it may be a little bit different procedure. I've already looked online. These are no longer made. They're in the surplus market maybe. They look fairly expensive. But if it's an ISO, I have two options. I can either find one off of a used machine, repair the one that I have, or actually convert it. If it is an ISO, I could just buy another valve body of a current manufacturer. The only thing I hesitate about doing that is usually the wiring, like I know in the ones that I've worked on in the past, they're basically you wire the wire directly to the solenoid itself. These have a connector, so I'd have to ditch that connector. So that's one reason for not doing that, is you'd have to cut into the wiring, which I don't really want to do, but I will if I have to. Anyway, I'm going to take you around the back of the machine, kind of show you where the leak's at and what's going on. Hopefully the air compressor won't cut on. If it does, I apologize. I'll do the best I can with a video, but it's difficult to work with the air compressor. And today it's really, really cold, and you notice I got my jacket on, so I won't be putting the air compressor outside. I'm just using my portable air compressor, not using the main shop air right now. So, okay, lighting's not the best in the world back here. I'll do the best I can. Basically, the air inlet is here. Basically, you connect air up here. It sends it through this tube and goes almost directly. It goes through a couple of panels. I've double checked to make sure there's no leaks there. And it goes into the top of this body. And I'll give you a shot of that close up here in just a second. But basically, there are 4 solenoids. I don't know the configuration on them yet. Hopefully they're labeled. The only thing that I can visibly see is that they're a DC 24 volt. They're made by NOK F-Tech, which I believe's got bought now. I think they still exist, but when I looked online on their website, they don't seem to sell this particular type of thing anymore. It does look like an ISO. When I plugged up the air, we had air coming out of the exhaust vent, which it should not be exhausting. Two possible things that could be happening. One, we could just have a leak in the solenoid itself, or 2, we may have a leak somewhere up in the machine that's allowing air to go through whatever pneumatic device or actuator that's there and coming out the exhaust port. That shouldn't happen. So what I'm going to do is I'm going to pull this off real quick and do a test. These all look the same. I'm going to take the first one off and try to identify that they are the same part. Got a couple options on repair, and this is more for if you're trying to repair your own machine or getting a better understanding of your machine. A couple of the options, a good method to test is actually just swapping out parts. If they're the same part, you do it all the time with relays, any kind of modular type stuff, you can swap it out. These are a little harder. These look like they have the standard ISO 4 hex bolts that actually bolt the thing to it. Another thing I'll caution you, and I don't have one, and hopefully I won't damage this one. If I do, you can cut those out by hand, but there's a gasket in between those. Usually these are running dry, so I don't expect to have an issue. It'll probably just come off and it won't be a problem. The only problem I've ever had with these is they're mounted in this direction. Normally when I work on them, they're this direction. On this machine, they're this way. So it's very similar to like a water pump on a truck or something. You're trying to mate up a gasket and a part. It's pretty difficult to do. And it seems like the 4 hex screws would help, but they actually don't, because as soon as one of those hex screws touches or vibrates or jitters as you're placing that part, it'll push that gasket right out and, you know, create another headache. Anyway, I'm going to pull this off and we'll take a look at it and see if we can figure out what's going on. I don't have a clue which one it is yet, so I'm going to go ahead and fire up the machine and go through all 3 of these operations on the machine and see if I can determine where the problem is, which circuit it's in. Okay, you can probably hear by that noise. I took one of the covers off the top. You remember when I said I thought I heard an echo? I wanted to check that before I took that whole valve body piece off. And sure enough, there's a leak. It's in the actuator for the tool chain carousel. And my guess is it's probably leaking past the seals, and that's what I'm hearing coming out the exhaust port. So it always pays, you know, check what you can. The solenoid swap wouldn't have been that big a deal. I'm not going to try that quite yet because I want to fix this. I know this is a problem. It looks really hard to get to, and it's kind of grimy. So I'm probably going to spend the next, you know, hour or so just cleaning up that area before I disassemble anything. It looks like a normal, normally the brand that I've messed with are Bimba air cylinders. Looks very similar. I'm going to pull it off, see if I can get some part numbers and maybe a parts diagram, just to take a look and see what I may need to repair this. Okay, we're about, I don't know, I guess an hour in. Probably spent about 30 minutes that I shouldn't have had to spend taking a cover off. Had a hex head bolt. I guess it was in a corner, and it, I guess some water or coolant had ponded up in the top of that bolt, and the head was basically non-existent. Anyway, I was able to get it off with a set of channel locks, and we got the leaky part out. Now this actuator actually actuates the carousel. You can see it's got a little nice little roller bearing. Everything looks okay. It does need to be cleaned very bad, but you can tell there's just a little bit of slop in that cylinder. So I'm expecting to see the leak is actually occurring inside of this cylinder. It's actually blowing by and going out the other exhaust port. So I'm going to get this cleaned up, get it all apart, and do an inspection and see what kind of parts we might need to replace this. I also had to do a slight modification. This particular shield I've never taken off before. It's on the rear of the machine. And they actually had a big busway for the wires to go through, which was metal and all bolted together. There was about a gap about that big where they actually, I guess they assembled the shield first and then put the wiring in. I cut that out. I want to be able to get that shield off later. There's no mechanical reason for that being there, so I got that out of the way. It's a little bit difficult. Ended up using just a metal cutting jigsaw, cut up, bent it out of the way, and pulled it off, and now I'll clean up the cuts, get it back on the machine. But I'll show you that in a second. But this is the air cylinder that's leaking, so we must have air going in. This is the exhaust port. Yeah, this is the exhaust port. So air was still leaking out of here, and basically what I did is unintentionally, there's a lot of debris. I've replaced the hose on this side. This hose here was dry and brittle, and actually popped off there inside the coupling. So I'm going to clean that up, fix that, and I'll replace that hose. This is just standard metric air hose. No big deal. Anyway, I'm going to pull this apart. We'll see what we find inside. Alright, this has been an adventure. We got the cylinder out. It didn't appear to be in the best shape. One real quick, easy way to test the cylinder, if you can get to it, is one, you can apply air if you have one of those little rubber adapters. Another easy way to check is just put your finger over the port, press in. You can kind of see there's air leaking both ways. If I stop off this end, I get a lot more resistance. on this end. So pretty much the air is coming out this port anytime that there's air applied to the back side. So it's probably the cylinders wore out. Typically you do have to replace the whole cylinder. I'm going to check and see. This did have a snap ring in it. I'm going to see if I can get it apart to repair it. If not, I'll have to find a cylinder that's got a similar stroke to this and do a replacement. The one thing that really got me is this piece right here. Oop. Okay, spotted that. That's the second time I've lost that. That was a snap ring that just fell. If you look right here, you see the little hole? That was a set screw. So if you look there, there's a set screw on each side. Well, not only are there double set screws, one for each side, there are actually double set screws on each side, one stacked on top of the other. That took me a little while to figure out because it's kind of a deep hole, but it's basically they had put two set screws into this. Something I haven't seen, but I thought it was interesting, and it may save somebody some time if they're working with industrial stuff and shafts on these pneumatic controls. For whatever reason, they chose to double set screw, one on each side, one on top of the one on each side. Anyway, I'm going to keep going. I don't know that we'll get this fixed today, but we did find the problem, and we have the part out, and hopefully we'll either get this repaired or order a new one, and if we have to, we'll machine up something to make something else work. This looks like a maybe 1.5 to 2 inch stroke. I'll measure it to be sure. It doesn't appear that it comes apart. When I first looked at it, I thought maybe this unthreaded, which was unusual because most don't. But that's not a thread, that's just where it's sealed. The only exposed thing that tries to come out maybe is this end was snap ringed. This end is solid. Most of these that I've messed with, these bodies are machined as one piece, and then there's a bore, and usually you can get this out, but not always. I'll play around with this a little bit, see if we can get into it. Okay, I did find the part, but I haven't found anything about rebuilding that cylinder. It appears to be crimped. The two ends are crimped or something onto that stainless steel tube, so that's not a user repairable part. The snap ring out, I think that snap ring's only holding in the outer seal. Anyway, I do have the manual for this machine, and I looked up that part number, and lo and behold, SMC Pneumatics, they still sell it. It's not super cheap, but they still make it. I think it's around 160 bucks. But I'm gonna do a little bit of research. I've got the series of cylinder just to see if anything cross references up with that. And if not, I'll order a new cylinder. Not a big deal. That cylinder is original, and it's lasted since '98, so not a huge investment to get this machine back up and running. I did play with it a little bit. One of the neat things that I found, usually on a cylinder, it completely wears out inside. There's a wear ring and a seal on an air cylinder. This particular one, it really doesn't afford itself the opportunity to rotate, and it must have a little bit of lateral load on it, because if I take the cylinder and I turn it, it seals up and works the way it's supposed to. Now I could, in theory, it would probably wear out in a very short amount of time. I could rotate that all the way around 180 degrees, and it may or may not leak. It doesn't leak in testing, but the amount of work that went into this, I'm going to show you what I actually had to do to get it in the machine. It's not worth it. It's better just to put the right part in and be done, even if I have to manufacture something for a more common cylinder. But this far, that looks like a common cylinder, and it looks like a pretty easy one to get. They even had them in stock at SMC, so shouldn't be a big deal. Anyway, I want to take you over the machine. We're going to kind of walk around it. Hopefully the audio turns out nice. Doing a little something different with this video. I'm dual recording audio and trying to get better audio for folks. A couple of folks have complained about, especially the outdoors, which is really just difficult to film anyway, because I usually don't set up what I'm about to film. It's just when a project comes up, I try to capture what I can. So if the audio is not that great, I apologize, but you know, it is what it is. Okay, we're kind of in the machine. Pretty much the tooling, a pair of channel locks to get that dang cap head screw out right there on the corner. You can see there's a big chunk of the machine shield missing on the rear because we needed to get to the back of the tool holder. Pretty much just metric. This is Japanese machine, Korean machine, so everything on it's metric. And that pretty much got me in there. I'll bet, you know, having to climb up and through. You can see that's not a really, you know, spacious area to be in. And you know, some of the woolly boogers have built nest that I got into coming up. Anyway, I'm going to walk around the back of the machine. This is kind of what it looks like at the front, and show you what I did. And I have not finished cutting that shield, but I'll show you what I had to do to get it out. Okay, I know probably for you this is not a unique view, but typically there's a big piece of steel here that covers all this up, and you can't. I've got the side door off. One nice feature of my machine, it comes off. It's got 2 screws, fits down this slot, and you can get over into the whole side of the machine. But you usually don't have this much light here because there's usually a shroud over this. I'll show you it in a second. You can kind of see this was the problem bolt. Didn't have any problems with this part, but I won't be putting that screw back in. And this is what we were after. This is the actuator. It basically presses in. That motor's turning, and it basically cams the tool carousel with these airlines. This is the airline that I replaced when I first got the machine, and this is the old airline. Those aren't super difficult to get to. They basically go into that chase, and you can kind of see in that crack there, they pretty much go straight down to this solenoid. So I may just replace all that while I'm at it, or I may come back and do it later. This was the problem area. That shield actually came and had a hole where this was at, so I guess the shield had put on first and then this was put on. So I elected to actually cut. What I did is I cut here first, and you know, bent it over so I could squeeze it between this space and lifted it off. I'll cut the other side later, but I'll show you the shield here in just a second. Okay, so here's the shield. It's a relatively big piece, and I basically have cut, and I'll probably do a round cut here. That way this shield can come on and off without any issues. Again, you know, this is nice and clean, and on the back side, especially on the lower where you can't really reach down into, it's kind of dirty, so I'll get all that cleaned up before I put it back together. Anyway, I hope you liked the video. It may be a little while before I do part 2 on this. If I get in a real bad rush, I may not even do a part 2 other than just mentioning in a video. Because pretty much it's going to be the reverse of what I just did. With either a new cylinder, definitely if I do a retrofit of the wrong cylinder or a different cylinder. This is fairly easy. This is literally just a plate. So all that I need here is just a cylinder that fits the threads of the actuator. That'll bolt up to this, which is literally just a piece of metal. I'll take you over to the parts area and show you that. Okay, so I've kind of got everything laid out here. This is a cylinder. This is the actual actuator, and that threads in the back. And then you have 4 set screws, 2 on each side, 1 on top of the other. And this is that plate that I was talking about. So that wouldn't be out of the question to retrofit something. Really all I would need is something with similar push force, speed, and that threaded rod would be important, although I could adapt this to whatever I want. But I'm going to shoot for sticking with the same part. This one's done well. There's no real reason to switch it, and hopefully I can get the same part and just do the reverse of what I did to get it all apart. Anyway, I hope you like the videos, and we'll see you on the next one.